Module 9, Lesson 3 covers the area of composite figures. A composite figure would be a combination of two things, like if you were to take a square and a rectangle and stick them together like you used to do when you were a little kid drawing a house. The suggested pacing guide says this is going to be a real quick 45-minute lesson. I hope so. Maybe we can knock it out in just one video. There are only 10 resources to go with it. The state flag of Ohio is the only non-rectangular state flag in the United States. The shape of the Ohio flag is referred to as a burgie or burgee. Don't really know how to pronounce that because it ends in a V-shaped cut called a swallowtail. Since the flag of the state of Ohio is an irregular shape, you cannot easily find its area. Describe how you could use decomposition, and no, we're not talking about rotting of dead things, the act of decomposing a figure into other shapes to find the area of the flag. These are the things we're going to be learning to do in today's lesson. A composite figure is defined as being made up of two or more shapes. Let's go ahead and highlight that vocab term. To find the area of a composite figure, you have to decompose the figure into shapes with areas you know how to find, and then find the sum of those shapes. So for example, this composite figure, you have a trapezoid and a rectangle. You would break it down into the two parts, the trapezoid piece and the rectangle piece. Find the area of each one of those and then add them up together. When analyzing the structure of a composite figure, look for shapes like this one, like the ones below, into which you can decompose the composite figure. So for example, it says drag the items to match the correct name into the formula. So first off, we have a parallelogram is here, a circle is going to be here, a trapezoid, that's going to be this one, a triangle, that's going to be that one. And now let's look at the formulas. The formula for area of a triangle we have right here. The formula for area of a circle we have right there. Get it to stick. The formula for area of a trapezoid, that's our ugly formula. That's going to be that one. And the formula for area of a parallelogram is going to be right there. Check it. And let me wiggle this one here a little bit. And now the whole thing checks quite nicely. Now, at this stage of the game, you should have all those formulas memorized because we've used them all in finding the area of two-dimensional figures. Ayana is painting a sign from a piece of reclaimed wood with the dimensions shown below. What is going to be the area of the sign? Well, if you take a look, that sign is cut into two individual pieces. You have a rectangular part and you have a triangular part, and we know the formulas for both of those figures, so we're going to start off by finding the area of just one of them. It says the figure is a pentagon, five-sided figure that is composed of a rectangle and a triangle. Now the rectangle is going to have a length of this distance right here, which is going to be 14.5, and a width of this distance right here, which is going to be 4. The triangular base, that's going to be this distance right here, which is also going to be 4. And the triangular height, well, that's going to be a little bit harder because there we're going to have to take and subtract the 14.5 from the 20.75, and that is going to give us the 6.25 right here. And so now we have all the pieces we need to get the answers for the area of these figures. Once again, to find the height of that triangle, I subtracted the total height of the figure and the height of the rectangle, and the difference was going to be the height of the triangle. Now the textbook wants us to find the area of each piece, and they're not really giving much space to show supporting work, so I'm going to pause the video here and set up a place for us to work on our separate document. Alright, I've had my problem set up, so I'm going to take and start off with the area of the rectangle. So the area, of course, is going to equal to the length times the width, where the length of the rectangle was going to be the 14.5, and the width of the rectangle, that's going to end up being 4. Area is going to equal 2. We multiply that out, that's going to give me 40, plus 16 is going to give me 56, plus another 2 is going to be 57, I believe, but let's go ahead and verify that mental math here. So I'm going to do 14.5 times 4. I'm going to do that. Oh, nope, should be a 58. Yeah, I should have got that right in my head. So the area of my rectangle, that's going to be 58. And then on the triangle, area is equal to 1/2 times the base of that triangle was going to be 4 times the height of that triangle was 6.25. And the first thing I'm going to do is I'm going to take out that 1/2 of 4. 1/2 of 4 is equal to 2. Whoops. Times my 6.25. And when I multiply that out, I get area is equal to 2 times 6.5 is going to be 12.50, or just 12.5. So I can jump back over here to the textbook now. I can put in my 58 right here. I can put in my 12.5 right here. Check and check. And both of those parts have checked correct. Next, all we're going to have to do is add those values up together. So you can see that they had 58 square inches for the rectangle, 12.5 square inches for the triangle, and we add those up together. That's going to give us 70.5 for our final answer, and it checks. That's all there is to doing these guys. You find the area of each little bitty piece, and then you add them up together to get the answer you're looking for. Now it's going to be your turn. Pause the video, work extra example 1 for this one. Give you a hint. You're going to need a rectangle and a trapezoid to solve this problem. How did it go for you? Well, first thing I'm going to have to do is cut up my trapezoid and my rectangle, and I think that going across here is probably going to be as good of a way as any. And now you can see I've got a rectangle that has the dimensions. It has a height of 13.34 and a base of 25 1/2. My trapezoid, however, is going to be a tiny bit harder to figure out. You're going to have a base 1 and a base 2, but I need to figure out this distance right here. That's going to be the height of the trapezoid, and to do that, I'm just going to take and start off by subtracting from 20 1/4. And what am I subtracting? I'm subtracting the 13 3/4 right here that is not part of the trapezoid. From there, we can take and I'm going to do some borrowing here to make my subtraction easier. I'm going to make that 19 5/4 minus 13 3/4. That's going to give me 19 minus 13 is 6. 5 minus 3 is 2 over 4, also known as 6 1/2. So this distance right here is going to be 6 1/2. And now I've got the foundation for doing my next step, which is to find the area of the rectangle. Area is equal to length times width. Area is equal to 25 1/2 times 13 3/4. I'm going to take those and change them to improper fractions using the Texas approach. 2 times 25 is 50. 50 plus 1 is going to give me 51 over 2. And 4 times 13, that's going to give me 40, 52, 53, 54, 55 over 4. From here, I'm going to multiply that out. And that's just not going to be real fun at all on the top. 2 times 4 is going to be 8. That's going to be easy. But on the top, we're just going to go ahead and save y'all some time. 51 times 55 is going to give us 2,805. And we're just going to leave that as an improper fraction right now because we're going to have to add that to our trapezoid in a little bit. The area formula for a trapezoid is 1/2 times the height times the sum of base 1 and base 2. So we have area is equal to the height of our trapezoid. We've already taken and shown you is going to be the 6 1/2. So I have 1/2 times 6 1/2. Base 1 is going to be this distance here, which is the same as this distance here. 25 1/2 plus base 2, 20 1/4 right there. 20 1/4. Next, area is equal to, I'm going to do 1/2, and I'm just going to go ahead and change this to an improper fraction, just to save some steps later. 2 times 6 is 12, plus 1 is going to be 13 over 2, times, and now I got to find a common denominator here, 25 and 2/4, plus 20 and 1/4. I got my common denominator. Area is equal to, I can go ahead and multiply these out, but I'm not going to do it because that technically does not follow PEMDAS. So I'm just going to keep writing it down. And then inside there, 25 plus 20 is 45. 2/4 plus 1/4 is 3/4. Good so far? Now it's time to start multiplying, which means I have 1 times 13 is 13. 2 times 2 is 4. Times, in here, we're going to do the Texas thing again. 4 times 45, that's going to be 180. And 180 plus 3 is going to give me 183 over 4. So now I have area is equal to, the bottom part's easy, 4 times 4 is 16. And the top part, I got 13 times 183. That's going to equal to 2,379. And I'm going to circle that. I'm not done with my problem yet. Now I'm going to have to add those two values together in order to get to my final answer. So moving to our final answer, the rectangle was 2,805/8, plus the trapezoid was 2,379/16. My least common denominator is going to be 16, so I have something over 16 plus something over 16. Let me go ahead and see if I can move this document up some a little bit. And now I can say, well, 8 goes into 16 twice, and 2 times 2805, that is going to be 56. Yep, 56, 10, plus 2379. Now I'm going to just make sure I did that mental math right in my head, where I took 2805 times 2, which did give me 5610, and now all I have to do is add that to the 2379 plus 2379. That's going to end up giving me 7,989 over 16. Wow, this problem is really getting ugly, isn't it? Let's take from there and figure out how many times it's going to go in. So I'm going to set up my problem just so I can do my round robin. 7,989 divided by the 16, but I'm going to totally cheat here. I'm going to take and divide 16 into that, which is going to give me 499. 499. And let's see if it'll allow us to let's see what the question asks us for here. Write your answer is a mixed number, so we're going to have to do that. So we're off to a good start for doing that. And we're going to take and say 4 times 16. That would end up giving me 64 right there. And I'm going to subtract that out, which is going to give me a 15 left over. Carry down the 8. 9 times 16, that's going to become a 54. 9 times 6 is 54. 9 times 1 is 9, plus 5 is going to be 14. I'm going to subtract that out, and that's going to end up giving me a 4 and a 1. And when I bring down this 9 right here, now I'm going to get, did I do something wrong? Nope, I didn't do something wrong. Now I'm going to end up getting 9 times 16 again, which is 144 again, and you subtract that out, you get 5. So my answer's 499 and 5 over 16 if I did everything right. So let's see if we did it right. That's an awful lot of work, and I sure would hate to be wrong. 499 and 5 over 16, except, and fingers crossed, we got it right. Now guys and girls, that is a lot of work. I'm not going to give you something like that on your test. I won't be that mean to you. what if I was on your test would be numbers that are much more doable, but you may very well see a problem like that on your homework, and you're just going to have to power your way through. Unfortunately, all that supporting work ate up a lot of time, so we are going to have to do 2 videos. I'm going to go ahead and stop this one right here, and we're going to come back for part 2 in just a little bit.